Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and welcome to 3D Collisions in GameMaker. So, we've got ourselves a very basic 3D collision system set up. We have a couple basic shapes. We have points, spheres, axis line, bounding box, lines, planes rather, as well as raycasts and line casts that we can do. And today we are going to not add anything new, but I'm going to spend a little bit of time showing off how you might use something like this in an actual game. So in our test environment, we've got 3D collisions detected. We can detect collisions between any two abstract shapes, so a sphere, a rectangle, anything like that. But this isn't anything that really resembles a game. Today I'm going to take a couple steps towards implementing this in something that looks like an actual game. So this is the 3D collision project that I've been working out of for the last several weeks. This is my test world that I have. It's fairly basic. We have ourselves a player in the form of a duck. We have trees, and you can't collide with the trees or anything like that. You can walk right through them. Additionally, if I hit the Z key, I've got a little debug draw. So we have some shapes showing the general shape of the different objects in this world. So our player character is a sphere. These trees are all rectangles. Again, you can walk through them. You can't collide with any of these. And implementing collision in here is going to be something that I'm going to be doing today. So first, a quick look through the anatomy of this project. Pretty much everything in this project is living in obj_camera. In the create event, I'm just going to open all these. In the create event, we have a vertex format, as you would expect. Enable the debug overlay so that you can see things such as how the game is performing. We have a vertex buffer representing the floor, which is being generated. All of the different tree vertex buffers are being loaded from files in the form of just buffers, just raw vertex buffers. No OBJ loading code happening here. Down here we have the player. The player is just represented by a struct containing a few variables: x, y, z, the bearing, the direction, the pitch, and the direction that you're facing, separate from the camera, as well as just some other things related to drawing. And we've also got a vertex buffer for the player, which is being loaded from a file. And then down here, there are the debug shapes. So there's the sphere, the block, and that's about it. The mouse is set to the center of the screen as soon as the game starts. In the step event, this is pretty similar to the code that I've been using in the general 3D tutorial demos to move around. So we're getting the direction, the pitch when you move the mouse around. You're checking to see if the game is going to end when you hit the escape key. Move around with WASD, with WASD, so you can move forward, backwards, side to side. And down here, this is mostly just for controlling the camera and which sprite frame you're being drawn with, which sprite frame the player is being drawn with. I've also left on purpose a little bit of commented out code from the earlier DLL-based collision system that I made videos on a while ago. And I'm not actually going to be using that, as you can imagine, because we're not using the DLL, we're writing our own collision system. But I've just got this code here commented out so that we can see what the old code looks like, and we're going to be writing something a little bit similar to that in this video. And then in the draw event, pretty basic. We've got a third-person camera. X2, Y2, Z2 is the player's position. X from, Y from, Z from is the player's position minus a certain direction where the camera's behind the player. Set the view matrix, set the projection matrix. This here is for drawing the player and figuring out which direction the player should be facing, because we're not so much a 3D object as we are a sprite that's being propped up in the air. And down here at the bottom, we are generating a bunch of trees in the create event. It's just a bunch of tree objects, which at this point basically just contains a position data, and drawing them in a loop. So this is a pretty simple project. I would not really recommend taking this code and using it as your own, because it's very basic. I threw it together in like a half hour before I sat down to record this, and it probably won't get you very far. But it'll be enough so that we can see a little bit of 3D collisions happening with the trees by the end of this video. Also, if you do, for whatever reason, want to use this project, you should probably give Kenny.nl credit for these tree objects, because that's where they came from. I tend to use them a lot in these demo programs. And I would ask that you don't use the duck sprite without permission from Alexandra Munin, the actual artist. Okay, so let's get out of there. I am going to jump back to the 3D Collision project, the original. I am going to turn this into basically a GameMaker library, a GameMaker extension. I made a video on how GameMaker extensions work a while ago. If you want to see that video, I will have a card popping out of the screen. Essentially, go to Tools up here in the menu bar, go to Create Local Package. I would just like to select the folder. I've organized all this into folders. I would like the collision stuff folder, which contains the helper functions script, the collision shape script, and the collision vector script. So we should be taking with us these 3 files. Just a little bit of code. Everything else isn't really needed. Everything else is just there for basically the demo and the test. Over here on the left, the publisher name is I'm just gonna call it like Drago or something. The display name is 3D Collisions. The version I'm just gonna leave at 100. It's not terribly important. None of this is terribly important. And the package ID is gonna be the file name. And again, I'm gonna call that 3D Collisions with no spaces or anything, all lowercase. Not terribly important. You can call it whatever you want. Let me go and save this. And once I open it in Explorer, you can see that it has spat out a file called 3dcollisions.yyMPS. That is the GameMaker extension. In your test world, you can add this by either going to Tools, Import Local Package, and finding that file wherever it went, or you can just go into Windows Explorer and drag it into the GameMaker IDE. Import Asset Package, yes please. We are just going to add the collision stuff folder. These 3 scripts, so call helper functions, call shapes, and call vector. Don't import all resources to a new project because that is not what we want. And then just import everything. And that will add the collision stuff folder and contents to the project. So we now have call helper functions, call shapes, call vector. Everything that we've written in the past. If I were to run the game now, nothing would happen. We're not just going to suddenly have collisions. We're still going to be able to walk through the trees. But the code has been added to the project, and we now do have the ability to actually use that collision code in the game world. So let's do that. First, I'm going to mark this as a commit. Added the 3D collision library code. If anything goes wrong, it would be nice to be able to revert to there. Next, I'm going to go and add some collision shapes to the various objects in the world. So the objects in the world right now are represented by structs. And again, I would like to stress that this is just an example. This is just a very quick and dirty example. Your own project that you may or may not be trying to add this to is certainly going to look very different depending on how you've written it in the past. I am not going to be writing any code that you are just going to be able to copy and paste verbatim. You're going to have to be able to adapt it to your own project, whatever form that may take. It's also worth noting that this is not going to be super optimized. I'm not going to be organizing the collision data into any sort of hierarchy that will allow us to optimize collision checks. I will be covering octrees and stuff in the future, but just not right now. So let's start with the player. If I run the game now, the player, as I mentioned, is approximated by a sphere. You could use an axis-aligned bounding box for the player if you want, but I'm going to be going with a sphere. The dimensions for this thing are 8 by 8, and it is centered 8 units above the ground. So its origin is the player's x, the player's y, and 8 units in the air. So I'm going to just tack on a variable to the player struct. I'm going to call it shape, and its value is going to be new call sphere. Spheres have a position, spheres have a radius. The position is going to be a new vector 3. Was it called vec3? Was it... What did I call it? It's just vector 3, but it does not have syntax highlighting for whatever reason. Alright. Whatever, GameMaker. New vector 3. And just going to take an x, a y, and a z. The y is just going to be the player's x and y, which is going to be 0, 0. Z is going to be the player's z plus, as I said, 8, because the sphere's origin is 8 in the air. And the radius is going to be 8. Okay, still do not know why vector 3 is not being recognized by GameMaker, why it's not being syntax highlighted. That's weird. Next, I would like to give trees something similar. I would like to give trees a shape. Trees are created with a constructor. rather than just an anonymous struct the way the player has. So I will go into the constructor. I will say self.shape is going to equal likewise new call, not vector, but call ab. I could construct the axis aligned bounding box with a central position and a set of half extents if I want. Possibly a little bit more usefully to me, there is in the helper function script a call ab from min and max, which might be a little bit more useful. So I can, and this is not a constructor, I can say call ab from min max, and the point min, I guess I'll just, I should also mention the dimensions of the axis aligned bounding boxes, which I am using to represent the trees. These are 16 by 16, they're 32 units tall, and they're, again, centered on the origin the same way that the player is. So the min point for the axis aligned bounding box is going to be a new vector 3. It's going to be -8, -8, 0. And the max point is going to be a new vector 3. It's going to be +8, +8, and 32, I believe I said. And that is going to be our axis aligned bounding box. Again, that's just the size that they happen to be in this world. In your game, they may be of some other size, and you will need to figure that out for yourself. Again, right now, if I were to just run the game, nothing would happen because we're not actually detecting any collisions. We just attach the collision data to each of these objects. Okay. The next step is going to be actually doing something with that collision information. I'm going to go into the step event of obj camera, and if you spent more than like 20 minutes, a half hour, whatever, on this, you probably got a dedicated player object, and the player object is probably not just a struct which is contained within the camera. You are just going to want to be in whatever step event is in charge of making the player move. So at the bottom of all this, at the bottom of this block, where I have dx plus equals the sign of the direction times movement speed and whatever, when you hit W, A, S, and D, when you move around, this is the potential movement. dx and dy, these are the potential movement. Looks slightly like calculus. I swear that wasn't intentional. Anyway, once all of the inputs are evaluated, dx is added to the x position, so the difference in the x, and dy is added to the y position, the difference in the y. Okay, so in the DLL-based collision video that I made last year, I was checking the x and the y axes independently of each other for collision, and I will get to that. I will be getting to that momentarily, but first, let's just do it nice and simple. I am going to for var I equals 0, I is less than tree count, I plus plus. That needs to be a lowercase I. Tree count is the macro which represents the number of trees in the world. That is the size of the tree array. So we're going to loop over every tree in the world. I'm going to say var tree is going to be obj underscore camera dot tree objects index I. We're going to look at each tree object individually, one by one. We can do that by saying if tree dot shape dot check sphere, spelling, it's hard. Because each tree object has a shape, which belongs to it, which represents the axis aligned bounding box, representing its collision shape. And we can have each tree's shape check to see if there is a collision with the player's sphere, which is just sphere, our own sphere. If that is true, we can say dx equals 0, dy equals 0, so we're not going to move. And because it doesn't really matter what happens after this point in the loop, we can just break out of the loop to save a little bit of processing. We are going to need the position of the sphere to actually be where the player is, at least where the player is trying to move to when you move around with the arrow keys. So we can say shape.position.x equals x plus dx. That is our prospective position. Shape.position.y equals y plus dy. So that is where we are looking to move to on the y-axis. And once this is all done, once we have finished evaluating our position, we can, at the bottom, after we've actually moved, shape.position.x is going to be set back to our own x and y position, whatever that happens to be, whatever the movement got evaluated to. That's just basic movement code. That's not anything specifically to do with 3D. Sphere is not set before reading it. Oh, it should be shape, not sphere. Hello. Okay, wrong variable name. Let's try that again. And I am not moving. Oh, you know what? I'm stupid. This is all, the tree collision objects are in the wrong place. This should be self.x minus 8, self.y minus 8, and the maximum extreme should be self.x plus 8, self.y plus 8, and z doesn't really matter because all the trees are on the ground. All the trees are at z equals 0. Okay. I imagine that several people were looking at their screens and yelling at me about that typo earlier when I made it. So I can walk up to the trees and I can not move through the trees. When I hit the trees, I stop. If I were to enable debug draw, you can see that I am pretty much getting right up close to the tree. And when I'm touching it, I am not able to go any further. This isn't perfect. I'm not able to, for example, slide across the trees. The way, if I were to hit them at an angle, if I were to walk into the tree at an angle, you would probably expect that the player just slides across the tree until you reach a point where there is, where I can move on. And the reason that I am not doing this now is because I am checking the X and the Y, collision at the same time. If you wanted to be able to move on each axis independently, you would do this essentially twice. Let us have another for loop. Let us move the collision shape position Y down here. In the loop with the X, if you encounter something on the X-axis, I am going to not set the Y movement, and likewise, when you're checking the Y-axis, I am not going to set the X movement. And then, let's see, right after the part of the loop where you check the X-axis, we are going to move on the X-axis. And we are going to set the collision shape's position on the X-axis to whatever that happens to be. Okay. The movement code that's been commented out has mostly been re-implemented. I'm going to just delete that, and I'm going to run the game now. And we are going to be able to move independently on each axis, and we're going to be able to now slide across the tree like this if you run into it sort of tangentially, or at least at an angle like this. So, on the X-axis, on the Y-axis, on some other axis. This still isn't perfect. There are some situations where you may get stuck in between trees. Visually, for example, here, it looks like you should probably be able to walk between these two trees, but if you turn on debug draw and you see where the collision shapes are, you see that that's not really the case, because the collision shapes are a little bit bigger than the actual trees. That is a game design choice, which you will have to work out. Figure out the most appropriate shape for all the objects in your game world. Okay, there's a bunch of places in this collision world when I was testing it out in which that happened, where it looked like I should have been able to walk through trees, but I wasn't able to. Like, there's another one. It's a little bit annoying. Another thing you may notice is in the debug overlay at the top of the screen, which I have turned on, since we have added this collision code, a lot of red has appeared when I'm moving around, and that is because checking for axis line bounding boxes and spheres is reasonably inexpensive compared to things like triangle collisions, which is why you generally want to do them. But at the end of the day, we are using GameMaker. GameMaker language is a unfortunately slow language. Checking 250 trees for collision both on the X and the Y axis will start to add up over time as a lot of work in the step event. And it does not help that this collision code is very object-oriented, because calling methods and whatnot does add a small amount of overhead every time you do it. If you were to rewrite this code in a more imperative coding style, you would probably see a slight boost in performance. I believe I mentioned that at the beginning of the series, and the reason that I chose not to do that is because this object-oriented style code is quite a bit easier to read, which I think is important right now. And then there's the fact that, like I mentioned, we are not doing anything by way of organizing this collision world into any sort of hierarchy that would allow us to accelerate collision checks, which is definitely something that you would want to do. If you have an entire large sprawling game world, it doesn't make sense to check for the player's collision against things that are all the way on the other side of the map when you're all the way on one side of the map. And if you do things like organize the world into a quad tree or into some other sort of spatial structure, spatial hash, you would be able to cut down immensely on the amount of computing that you have to do in order to do collision checks. So, let's see. One more thing that I would like to do is I would like to add the ability to jump for the player. Right now, we can move on the X and the Y axis. That's pretty nice. I'm actually going to make that a commit. Player can detect collisions on the X and the Y axis. And let's go about adding a floor. Actually, first, let's go about adding gravity. So, gravity is pretty simple. Gravity is a persistent downwards force. I am going to, in the player struct, initialize z speed equal to, you need a colon there because this is a struct. Z speed is going to be set equal to 0. In the step event, let's see, what values for gravity do I have in my test project? Okay, down here at the bottom, after movement is evaluated, after horizontal movement is evaluated, I am going to say if keyboard check pressed vk underscore space, then z speed is going to be equal to 2. After that, z is going to plus equals z speed, and z speed is going to minus equal 0.075. These numbers are all very hard-coded. This is just what happens to feel sort of like gravity in this world. I'm going to run the game now. We're going to fall through the floor because there is nothing stopping us from falling through the floor and our position updating through the floor. When I jump, you can see we're going in the air. There's nothing checking when we jump to see if we're on the floor. So we can just sort of infinitely jump. I guess we're a duck. We can fly. That makes sense. If I were to sort of try and move over one of these trees, you can see that I am stopping at the trees, even though I am above them right now because we are still only checking horizontal collisions with these things. Again, if I were to fall through the floor, I am also unable to go underneath the trees. Let's see if I can get back up to the surface. We're almost there. This is stupid. Anyway, I can't go through the trees. Alright. So the first thing that I'm going to do is I'm going to add a floor. And there's a couple ways you could go about doing that. You could add a separate object somewhere else in the game to represent the floor. I'm going to sort of hijack the tree objects array, and I'm going to create a floor object. The floor object is going to be another constructor, another struct constructor. I'm going to say function floor object with 2 O's, if you please. And this is also going to be a constructor. I don't need all this garbage. X and Y is going to be 0, although that doesn't really matter for us right now. The model is still going to be the model. The shape is going to be, instead of an axis line bounding box, the shape is going to be a new call plane. It's going to have a surface normal, which is going to be a vector 3, indicating the direction that the plane is facing, which for our purposes is going to be new vector 3, 0 on the X, 0 on the Y, and 1 on the Z. 1, 1. And a distance from the origin. And since the floor is going to just be lying flat on the XY plane, flat at Z equals 0, the distance from the origin is going to be 0. Okay? So that's the floor object. Again, very basic. Probably not something that you really want in an actual game, because it won't get you very far. I'm going to just insert one of these at position 0 in the tree objects array, even though the floor isn't really a tree. Tree objects index 0 is going to be a new floor object. The vertex buffer is going to be VB underscore floor. VB underscore floor. So that's what we're going to draw. And the collision shape should be automatically dealt with when the floor object is instantiated. Now, instead of saying for I equals 0, I is less than tree count, I'm going to say for I equals 1, I is less than tree count, because we want to start inserting the trees at position 1 in this array, because index 0 is already occupied by the floor. And I suppose I don't really need to draw the floor twice, because the floor is automatically going to be drawn now, because it belongs in the tree objects array. And I can just comment out that vertex submit. And if I run the game now, the world is going to look normal. You will see, however, that I am falling through the floor. Okay, the game wasn't supposed to work, but it was supposed to not work in a different way. Give me a moment. Heh, that's right. I'm not actually checking to see if we're colliding with the floor anywhere. It's a bit of an oversight. So, underneath this movement code, where we hit the spacebar, I'm just going to put this right underneath where we hit the spacebar. I'm going to do something similar to the horizontal movement code. I'm going to say shape.position.z is going to be equal to z plus z speed And again, we need to add 8 to this because the sphere's position is 8 units above the player's actual position in the world. And then once we're done with that, if a collision is detected, we can set z speed equal to 0. The reason that I'm making this a separate variable instead of something like dz is because z speed needs to persist because gravity is persistent and gravity accumulates over time. Gravity causes your downward motion to accumulate over time. And when you land on the floor, or at least when you detect collision with something beneath you, we are going to set z speed equal to 0. And let's see, the same way that after we update our x and y position, we are going to update the actual position of the collision shape in case z speed was set to 0 or something like that, or updated in some other way. We're going to do the same with shape.position.z down here, and that should cause us to actually stop when we hit the floor. Okay, good. So there's going to be a slight problem here, which is that I am not falling through the floor, but I also am not moving in any other direction. And the reason for that is that the game is considering there to be a collision with the floor if the bottom of your sphere is actually touching the floor. If you go into the shape collision code, go to plane. Where are we? Plane sphere, sphere plane, sphere and plane. If the nearest point from the plane to the sphere is less than or equal to self.radius, then that counts as a collision. So if the sphere has a radius of 8, and if it's exactly 8 units above the plane, then 8 is less than or equal to 8, a collision is detected. The easiest way I find, and you may disagree, but I find the easiest way to deal with this is to simply add a nominal amount to the shape.position.z. I'm going to just plus equal something like 0.1 when we're checking horizontal motion, and then once we're done checking horizontal motion, after these two loops have run, after the x and the y positions have been updated, we are going to subtract that same nominal amount. So we're going to add 0.01, and I'm going to make it 0.01, not 0.1, just because any nominal amount should do. We're going to add that amount to the sphere's z position, and we should be allowed to move again, and indeed we are. So we're not falling through the floor. I can jump. I can land back on the floor. I can run into the trees. Okay. This should be, and we're sort of sinking through this tree because the shape of this tree is slightly smaller than the actual visible model. As you see, this also works for landing on trees. If I were to sort of jump up in the air and try and land on one of these trees, you can see this also works here. And I can also jump and land on one of these trees here, and that's pretty handy. You can see, as before, the amount of CPU usage that is being consumed, the amount of CPU time being used by this collision checking is steadily going up. We are now, instead of checking each object in the game world twice for collision, we are now doing it 3 times, which is obviously not really what you want, although the second one isn't really running that many times because the floor is the first object in the array. But technicalities. Anyway, this is a bare bones 3D collision system. There's going to be much more to come. If you want, you can. I haven't done anything with raycasts in this demo, but you can very easily do something with raycasts. You can make the duck wave his wizard staff and cast a spell into the trees, and when the spell hits a tree, you can have it like catch fire and explode or something. Maybe more practically, when you move the camera through a tree, you might not really want the camera to like clip through trees. So you might want to do a raycast from the player to the camera, and try and place the camera in front of any obstacles, so that you can't like put the camera inside trees like this, because that's a little bit weird. Play around with this. Anyway, this is a very basic, bare bones, unoptimized 3D collision world. All right. This feels good. This is really the end of the first major milestone in this 3D collision series. So what's going to be coming next, I'm going to take a, hopefully, short break from this, and then I'm going to be moving on to things such as triangle meshes, collisions with triangles, which I think is going to make a lot of people excited because that's going to allow you to do things like collisions with terrain. If you have a hilly terrain and you want to do proper 3D collisions with it, it'll allow you to do collisions with more complex shapes, although for purposes of efficiency, that's not always really something that's helpful to do in an actual game. It's generally much more helpful to have basic shapes for things in the game world, such as rectangles for trees and either spheres or capsules for the player and that sort of thing. Also, this one next to me, this doesn't really exist. This is just like the The floor object is drawing its collision shape in the center of the room, even though it's really a plane. In case anyone was wondering what that was. As well as optimizing collisions, I am going to start talking about organizing the collision world into definitely an octree, possibly a spatial hash, which is sort of like an octree, but it's a different principle.
Hey.
And the 3D wizard known as the Snyder, at the very least, has informed me that they perform slightly better than octrees, so we'll see. Anyway, we should be able to see this same 3D collision world run much more smoothly in the future. And then at the end of all that, once I finish dealing with triangles and 3D collision worlds and other such things, I will once again export the collision library into a GameMaker package, into a GameMaker extension, add it into this test world, and we will do a little bit more with this test world after that. So, I'm gonna stop. My name is Michael. I like wizards and dragons and making games. I try to post about 2 game dev videos a week, one tutorial like this, and one let's make a tower defense game, as well as just a whole bunch of let's plays, so if you're interested in any of that, feel free to subscribe. If you want the code for this, look for the GitHub repository down in the video description. I'll have links to the GitHub for both this test world, as well as just the 3D collision project itself down in the video description this time, since they're both relevant. I have a Patreon, so if you want to contribute towards these videos being made, look for links to that in all the usual places. You can see your name in the credits, see these videos a day early, get a bit of a preview of my future plans, that sort of thing. I would definitely appreciate it. Otherwise, I hope you all found that useful, and I will see you all later. Special thanks to Connor, David Key, Edward Holt, Emily Koyo, Halo Factory, Posho, Sindra Larson, Tusk, and Zenith for supporting these videos. If you want to see your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page down in the video description to join the fun.